Let's continue with the exercises for chapter 7. Starting with the multiple choice questions, the uniform probability distribution is used with a continuous random variable. For a uniform probability density function, the height of the function is the same for each value of x. For a normal distribution, a negative value of z indicates that the z is to the left of the mean. Z is a standard normal random variable. The probability that the z is between 1.41 and 2.85 equals what? So let's see what we have. Since you're looking for the z value, that means that these are your z-scores. It also indicates that you have a standard normal probability distribution. Based on the main properties, a standard normal probability distribution has mu equal to 0. 1.41 is to the right, 2.85 is also to the right, and I'm looking for the area between these two values. All you need to do is check your table for 1.41. 1.41 will give you a probability of 0.4207. 2.85, this area from 0 to 2.85 will give you a probability of 0.4978. And since you're looking for an area between two values that are on the same side, which means that the mean is outside that area, or in this case between two positive z-scores, then we have to subtract the smallest from the largest. So the answer in this case will be C. Which of the following is not a characteristic of the normal probability distribution? That would be that the standard deviation must be 1. The standard deviation must be 1 for a standard normal probability distribution. As far as normal probability distribution is concerned, you can have any mean and any positive standard deviation. The normal distribution has a mean of 0 and a standard deviation of 1. As I just mentioned, this would be false. Let's start with the problems. The weight of football players is normally distributed with a mean of 200 pounds and a standard deviation of 25. So mu is equal to 200, sigma is equal to 25. I'm looking for the probability that a player weighs more than 241.25 pounds. This is the probability I'm looking for. We draw the normal curve. Mu is 200. 241.25 is to the right. I'm looking for the area that x is greater than 241.25. Therefore, I'm looking for this area. We find the z-score for 241.25 minus 200 over 25. The z-score will be 1.65. This is when you check on your table for 1.65. 1.65 will give you the area from the mean to the value. In this case, it's going to be 0.4505. And since I'm looking for a tail, I'm subtracting from 0.5. 0.5 minus 0.4505. This will be equal to 0.0495. So the answer will be 0.0495. What is the probability that a player weighs between 180 and 220 pounds? We calculate the two z-scores. I'm looking for the probability that x is between 180 and 220. We calculate the z-score for each value. So 180 minus 200 over 25. This is going to be equal to negative 0.8. The z-score for 220, this is going to be 220 minus 200 over 25. This is going to be 0.8. We take the absolute value and we check for 0.80 on our table. So 0.80 will give me a probability of 0.2881, and the same on the other side, 0.2881, since I have the same z-score, Since I'm looking for an area between a negative and a positive z-score, or if you want to look at it in other terms, an area where the mean is inside the area we're looking for, then we add the corresponding probabilities. So 0.2881 plus 0.2881, this will be equal to 0.5762 for the area. The life expectancy of a particular brand of tire is normally distributed with a mean of 40,000 and a standard deviation of 5,000 miles. What is the probability that a randomly selected tire will have a life of at least 30,000 miles? At least. At least means X greater or equal to 30,000. The equal sign doesn't really make a difference in our probability, since we have a continuous probability distribution. We calculate the z-score for 30,000. 30,000 minus 40,000 over sigma is 5,000, the standard deviation. So your z-score will be -2, and of course we expect it to be negative, since 30,000 is less than the mean, which is 40,000. If you look up the z-score 2, the corresponding probability is 0.4722. This part of the area that I'm looking for is 0.5, so all I need to do is add them. So 0.4722 plus 0.5, this is equal to 0.9772. That's your answer. What is the probability that a randomly selected tire will have a life of at least 47,500? In this case, same problem. I'm looking for X to be greater than 47,500, which is to the right of the mean. Greater than this number indicates the area to the right. Therefore, I'm looking for a right tail. The z-score will be 47,500 minus 30,000 over 5,000, and this is equal to 1.5. 1.5 will give you a probability of 0.4332. Since I'm looking for a tail, I subtract from 0.5. 0.5 minus 0.4332. This will be equal to 0.0668 for the answer. So this area will be 0.0668. What percent of the tires will have a life between 34,000 and 46,000 miles? We calculate the two z-scores, the corresponding values, the z-scores for the two corresponding values. This is the area we are looking for. The z-score for 34,000 is going to be 34,000 minus 40,000 over 5,000, and this is going to be negative 1.2. The z-score for 46,000 is going to be 1.2. When we look at the z-score 1.2, the corresponding probability is 0.3849. The same on the other side, 0.3849. And to find the whole area, I simply add the corresponding probabilities. So this probability will be equal to 0.7698. 0.7698. The weights of items produced by a machine is normally distributed with a mean of 8 ounces and a standard deviation of 2 ounces. What is the probability that a randomly selected item will weigh more than 10? So you're looking for x to be greater than 10. Mu is 8. 10 is to the right. I'm looking for a right tail. If you calculate the z-score, you will have 10 minus 8 divided by 2, which is equal to 1. 1 corresponds to a probability of 0.3413. And since I'm looking for a tail, we will do 0.5 minus 0.3413, 0.1587. 0.1587 for the answer. Since I'm looking for, let me just, what percent of the items will weigh more than 6.4? Same problem. 6.4 is to the left of the mean. More than 6.4 is the whole area to the right, the shaded area that you see here. The z-score is 6.4 minus 8 over 2. 6.4 minus 8 over 2, this is going to be negative 0.8. Negative 0.8. When we look it up, we take the absolute value, so we look up for 0.80. The corresponding probability will be 0.2881. 0.2881. This area is 0.5, is the half. Therefore, I add the corresponding probabilities. So this probability will be 0.7881, or if I'm looking for the percent, 78.81%. The assembly time for a product is uniformly distributed between 6 to 10 minutes. Find the probability of assembling the product between 6 and 7 minutes. So this is your graph from 6 to 10. I'm looking for the area between 6 to 7. So all you really need to do is 7 minus 6 over 10 minus 6. So this is going to be 0.25. Find the probability of assembling the product between 7 to 9. You will take 9 minus 7 over 10 minus 6. And this probability will be equal to 0.5. Calculate the expected assembly time in minutes and the variance. So we have alpha, A is 6, B, beta is 10 divided by 2, so the expected value will be 8. And for the variance, we're going to do 10 minus 6 squared over 12. So this is going to be 1.333. And this completes the exercises for chapter 7.